Hello everyone, welcome to the lesson Lists as Stacks and Queues, which is part of the course Python Programming. In this lesson, we will introduce the queue and stack data structures and discuss how to build them using lists. This is the color coding we will be using throughout this lesson. Let us start with a brief introduction to stacks and queues. Stacks and queues are widely used elementary data structures. We call them elementary because they are straightforward and there is nothing complicated about them. One important property of stacks and queues is that their insert and delete operations are pre-specified. This means you cannot change how insert and delete operations are carried out. Are you interested in learning how they are carried out? That is what we are going to discuss throughout this lesson. In our first course, Python for Beginners, we learned about lists in detail. In this lesson, we will discuss how to use lists as stacks and queues. The first data structure we are going to look at is stacks. One of the easiest ways to understand stacks is by looking at an example from our daily lives. Consider a scenario where you have some boxes and you have to place them on top of each other. You get your first box and place it on the floor. You get the second box and place it on top of the first one. Finally, you get the third box and place it on top of the second one. Now, we have a stack of 3 boxes. Then, a friend of yours comes and asks you to hand over the boxes to him or her. How do you remove the boxes? The first box you remove is the third one, which you have placed last. Then, the second one. You cannot remove the first box at the bottom without removing the boxes on top. Now, how is this example relevant to stacks? Placing the boxes on top of each other is similar to insert operation in stacks, and removing the boxes is similar to delete operation in stacks. Let us list down the properties of stack data structure from our box scenario. First, when you place boxes on top of each other, it creates a linear structure. There are no branches. Similarly, stacks are also linear structures. Second, the box you placed last is removed first. Last in, first out. Similarly, in stacks, the element you inserted last is deleted first. Third, how you place and remove boxes is fixed. You can only place boxes on top of each other and remove boxes from the top. You cannot insert or remove boxes at random locations. Likewise, in stacks, you cannot insert and delete elements at random locations. You can only insert and delete elements at the end of the stack. Now that we know the fundamentals of a stack, let us look at an actual stack with some values. We are going to insert the following 4 numbers, 17, 8, 13, and 5 into a stack. First, we insert 17. In stacks, we need to keep track of the last element inserted. Why? Because when we delete the last element inserted, and when we insert to the end of the stack. Now that we know why we need to keep track of the last element, the next question we have to ask is, how do we achieve it? It's simple. We keep a pointer to the last element. In this example, the pointer named top is performing the task. Next, we insert 18 and the pointer top is shifted from 17 to 8. Then we insert 13 and finally we insert 5. In the context of stacks, we use the term push for insert and pop for delete as shown in the diagram. So far, we have learned about the properties of a stack. Now, it's time to look at how to implement a stack using a list. Pause the video and think for a moment. What are the requirements to implement a stack using a list? First, we need a list. Second, we need a pointer for the last element. And finally, we need the push and pop functions. We have our list of requirements now. Let's move on and discuss how to implement a stack using lists in Python. First, let us create an empty list that is going to be our stack. I have named my list my stack. The next step is implementing the push and pop functions. The push function should be able to insert a given element to the end of the stack. In the implementation given here, the function takes a stack and the new value to be inserted as inputs. The append method available to lists is used to insert the value at the end of the stack. The pop function should remove the last element inserted. In the implementation given here, the function takes a stack as input. The pop method, which is a built-in method available to lists, is used to remove the last element of the list. The removed value is returned by the function. Since the list data structure has a built-in method to remove the last element, we do not need a pointer to keep track of it. Now, let's insert a few elements into the stack that we have created. To insert A, we call the push function with myStack and A as input parameters. It will insert A at index 0 of the list. Next, we call the push function with B as the input parameter. It will insert B at index 1. Similarly, we insert C at index 2 of the list. To confirm our insertions, we can simply print the stack. You can see that the elements have been inserted correctly. Now that the insertions are complete, let us move on to deletion. To delete a value from our stack, we call the pop function we implemented with myStack as the input parameter. As shown here, it returns C, which is the last element we inserted. When we call pop again, it returns B at index 1, and finally, the pop function will return A at index 0, leaving us with an empty stack. I believe you are clear at this point how to implement a stack using the list data structure in Python. Before moving on to our discussion on queues, let us look at an application of stacks. One of the simplest examples is the undo function. Suppose you want to draw a triangle. This is the stack we will be using to keep track of the changes. You draw the first line, which is the first change you make. Then you draw the second line, which is the second change. And finally, when you try to draw the third and last line, you make a mistake. You can correct it by using the undo function, which will remove the last change you made. It is similar to the pop operation in a stack. Now, you can redraw the last line correctly. This example clearly illustrates how useful stacks are. The second data structure we are going to discuss in this lesson is queues. Let's start our introduction to queues by looking at a real-world example. Assume a scenario at a bank where people are coming to deposit money. People form a queue in the order in which they come in. The person who comes first stays at the front of the queue. The person who comes in second stays behind the first person. Similarly, the person who comes in third stays behind the second person. Now we have a queue with 3 people. I believe you all are familiar with how queues work in real life. The first person in the queue who entered the queue first deposits the money and leaves. Then the remaining people in the queue move 1 position forward. Now the person who entered the queue second deposits the money and leaves. This pattern continues until the last person. The queue data structure also works in a similar fashion. Let us identify the properties of a queue from the previous example. First, the queue is linear. It does not have any branches. There is only 1 line. Second, the person who enters first leaves first. First in, first out. Third, How people join and leave the queue is fixed. One can only join at the end of the queue, and only the person at the front gets the chance to take care of business and leave. One cannot come and join at random locations or takes care of business and leave without being at the front. Now that we know the fundamentals of a queue, let us move on to building an actual queue containing some values. We are going to insert the following four numbers, 17, 8, 13, and 5, into a queue. First, we insert 17. As shown here, a queue has a head and a tail. Insertion takes place at the tail of the queue, and deletion happens at the head of the queue. Next, we insert 8, 13, and finally 5. After inserting all the four numbers, this is what our queue looks like. In the context of queues, we use the term enqueue for insert and dequeue for delete. Enqueue operation adds an element to the tail of the queue, and dequeue operation removes an element from the head of the queue. So far, we have learned about the properties of a queue. Now, let us look at how to implement a queue using a list. Pause the video and think for a moment. What are the requirements to implement a queue using a list? First, we need a list. Second, we need the pointers to the head and tail of the queue. And finally, we need the enqueue and dequeue functions. We have our list of requirements now. Let us move on and discuss how to implement a queue in Python. First, we create an empty list which is going to be our queue. I have named my list my queue. Then, we implement the enqueue and dequeue functions. The enqueue function should append the given value to the tail of the queue. In our implementation here, the enqueue function takes the queue and the new value to be inserted as input parameters. The append method, which is available for list data structure, is used to insert the value at the tail of the queue. The dequeue function should remove the first element. In our implementation here, the function takes the queue as input parameter. The pop built-in method is used to remove the first element. The pop method should be called with parameter 0 to specify index 0. The removed value is returned by the function. Since Python has built-in methods to remove from the head and append to the tail, we do not need separate pointers to the head and tail of the queue. Now, let's insert a few elements into the queue that we have created. To insert A, we call the enqueue function with myQueue and A as input parameters. It will insert A at index 0 of the list. Next, we call the enqueue function with B as the input parameter. B will be inserted at index 1 of the list. Similarly, we insert C at index 2 of the list. To confirm our insertions, we can simply print the queue. You can see that the values have been inserted correctly. Now that the insertions are complete, let us move on to deletion. To delete a value from our queue, we call the dequeue function we implemented with myQueue as the input parameter. As shown here, it returns A, which is the first element we inserted. When we call dequeue again, it returns B, which is the second element we inserted. I believe you are clear at this point how to implement a queue using the list data structure in Python. Let us look at an application of queues, which is file reading in computers. Consider a scenario where we have several files stored in a disk. There are 3 programs running in parallel, and they need to access multiple files. However, our hard disk can read only one file at a time. Hence, what it does is, it keeps a queue where all the incoming requests are stored. In this example, program P2 has made the first request to read a file. P1 has made the second request, and P3 has made the third one. Using a queue ensures that the program which makes the request first will receive the file first, which ensures fairness. This example clearly illustrates how useful queues are. We have reached the end of this lesson. I hope you enjoyed learning about how to use lists as tags and queues. Thank you.